Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at points of intersection. We're going to have a look at points of intersection of two graphs. Now, the point of intersection of two graphs is where the graphs cross each other. And in equation form, if we're thinking about them being two equations, that's where the equations are equal. So the point of intersection of two curves, one having equation y is equal to f of x, and the other having equation y is equal to g of x, is the solution to the equation f of x is equal to g of x, okay? Because that's where the two graphs cross, their coordinates are the same, so the two equations must be equal. Okay, let's have a look at two examples, and then that's all we really need to do for point of intersection. It's quite simple. The first thing we want to do for this example is, on the same axes, sketch the graph of y is equal to x times x minus 3, and y is equal to x squared times 1 minus x. Then what we want to do is we want to find the point of intersection. So like I just said, it's where the two graphs cross each other, it's where the two equations are equal. So try and solve when the two equations are equal. So pause and have a go if you want to, and then we'll work through the answer. Okay, hopefully you've had a go. If you didn't manage to sketch them, you managed to solve, that's fine. But let's have, first of all, a look at how we can sketch them. So to sketch, what I'm going to do is I'm going to have a look at the roots. To do that, I'm going to set the graph equal to 0. So x times x minus 3, set that equal to 0. Oops, let's make that 3 a little bit better. That means each bracket can be equal to 0. Here we kind of have an invisible bracket. So that tells me x is equal to 0 or x is equal to 3. So either of those, I'll write them in yellow, either of those is a solution to our graph or our equation. So those are the roots of the graph. So x is equal to 0, I'll do it in yellow. X is equal to 0 or x is equal to 3, okay? And I'll draw those on as well. We've got 0 and we've got 3. Now we need to think, what actually is the graph? If we were to expand, we'd have this, x squared minus 3x. So it's a positive quadratic because we're looking at the quadratic term. It's positive, so it's a positive quadratic. So the graph, and I'll draw it in red, we'll highlight it in red here, is actually a nice graph that, let's make sure it goes nice and smooth, that looks like that, okay? That is the quadratic, okay? Crosses through at 0, crosses through at 3, and then it can kind of continue, as we know, continues all the way up there. Okay, let's have a look at this graph. I'll highlight this graph in green because that's the colour we'll draw it in. To find the roots of that graph, all we need to do is similarly set it equal to 0. So each bracket can be equal to 0. There we've got two brackets, so we can have x squared is equal to 0, or from 1 minus x being equal to 0, x is equal to 1. X squared is equal to 0, so x is equal to plus or minus 0, which of course is just 0, okay? So those are the two roots, and I will draw those in, let's do them in grey, so it's not the same colour as the graph. If we draw them in grey, 0, I'll do it as a little dot, is there, and x is 1 is about there, okay? So what we have here is, well, let's think, we have, if we were to expand it, I'll do it in red, we have x squared minus x cubed, okay? Let's write that 3 a little bit better. So if we look at the highest power, we've got a 3, and that term is negative, so it's going to be a negative cubic graph. Okay, so what's going to happen is something like this. Now let me just turn the page to make sure I draw this correctly. It's going to look something like this. I'll draw it in green. It's going to kind of come down like this. It's got to pass through that root. It's then got to bounce off the root and come back down to pass through there, which is 1, and then continue down like that. Okay, Maybe that could have been a little bit neater, but as long as you get the right shape of the graph, that's all we need. And if you were to check it with a graphing package, that's what it would look like. We can see this quadratic graph is a little bit more stretched to the sides than this graph. And that's because the roots are more separated. So we need this graph to be like this. These roots are quite close together, so it comes down, hits that root, and then bounces up to pass through this root, to then pass all the way down. So there's our sketch, and now what we want to do is find the points of intersection. The reason I asked you to sketch the graphs is because that really helps you. We could have straight away just set the graphs equal to 0 and found the points of intersection, but because we've got a graph, we can see that, and I'll highlight them in orange here. We've got a point of intersection there, we've got a point of intersection there, we've got a point of intersection there. I'm looking, and I'll just make them a little bit darker, I'm looking for the points where the red and the green graph cross. Okay, so that's there, there, and there. Now they've both got the same root, so of course they're going to cross there at 0, and we've got then 2 other points. So in total we have 3 intersection points. So that means we're going to have 3 solutions when we set the graphs equal to each other. So let's do that, and that will find what those points of intersections are. So we'll have x times x minus 3 from this graph here is equal to the green graph, which is x squared times 1 minus x. Now we cannot divide by x here because x can be 0, so I'm going to expand the brackets, then get everything on the same side. So I'm going to have x squared minus 3x is equal to x squared minus x cubed. Okay? I'm then going to add x cubed to both sides and also take x squared off. So I'll have x cubed minus 3x is equal to 0. Okay? And let's just check that's correct. That's what we should end up with. Okay? Then all I'm going to do is I'm going to factorise. I can see they both have a common x, so I can take out an x to give me x times x squared minus 3 is equal to 0. Then, if I was to kind of put a bracket around that, we can see either bracket can be equal to 0. So that tells me x is equal to 0, or x squared minus 3 is equal to 0. Okay? And then if I solve this, I will have x squared is equal to 3. So then x is equal to plus or minus the square root of 3. Okay? So those are my 3. And I've got 3 here because we've got a plus and minus. Those are my 3 x values at the points of intersection. Okay, we've got a negative x, which clearly has to be this value here. If I was to draw down, we can see that's the negative, which is minus root 3. We have the 0, which we kind of knew because 0 was a root for both graphs, so they both crossed at 0. And then here, that's going to be root 3. Okay, so maybe my graph's slightly off because it's a little bit past it. Or maybe it's right actually, but we'll put it on anyway. That is root 3. Okay, that point there. Okay, so those are my x values. Now what we need to do is work out the y values. So if we substitute those back in, either to this equation or into that equation. I'm going to do it into this one here. So I'm going to substitute into y is equal to x times x minus 3 because I think that's a little bit simpler than this one here. And I'm getting those two equations from the 2 equations of the graphs. Okay, so either one you can substitute into, but I'm going to choose that one. So substituting x is equal to 0 clearly gives me y is equal to 0. Okay, draw a little line here to separate my working. If x is equal to positive root 3, then what we're going to have is y is equal to root 3 times root 3 minus 3, which is 3 minus 3 root 3. Okay, which is correct. And then if we have a negative value of x, so negative, let's put equals, negative root 3, we'll have y is equal to negative root 3, just zoom in a little bit here, negative root 3 times negative root 3 minus 3. That's going to give me, well, expand the bracket, just make it a little bit easier here. Expand the bracket, we'll have a positive 3 and then plus 3 root 3. So those are my coordinates. I can see x is 0, y is 0, so that's 1 point of intersection at 0, 0. X is positive root 3, y is equal to 3 minus 3 root 3. So my next point of intersection is x is root 3 and then y is 3 minus 3 root 3. That is another point of intersection. And then here we've got x is equal to minus root 3 and y is equal to 3 plus 3 root 3. That's the third point of intersection. Okay, let's have a look at example 2. On the same set of axes, we want to sketch the graph of x squared times 3x minus a and y is equal to b over x, where a and b are both positive constants. Okay, so might be a little bit tricky that one, but do have a go. Then we want to sketch and state with reason, using our sketch, state with reason the number of solutions to this equation here. Okay, so first of all, have a go at A. If you get a little bit stuck, think about the roots of the graph. Even though we don't know what A and B are, well, B is a little bit easier because we've had a look in the previous video, but as long as we don't know what A is, we can still work out one of the roots in terms of A. So pause and have a go, and then we'll work through the answer. Okay, hopefully you've had a go. So I'm going to sketch here. I've got x squared times, I'll write it down here so I can see, x squared times 3x minus a. So to sketch that, I'm going to first of all find the roots. If I set it equal to 0, and we're sketching on the same axes, yes we are, set it equal to 0, I'll have x squared is equal to 0, or 3x minus a is equal to 0. Then let's just solve both of those equations. That gives me x is equal to plus or minus 0, which is 0, or x is equal to a third of a. Now, it says both a and b are positive constants. So a third of a is also positive, it's greater than 0. So we know this root is going to be somewhere along here, depending what a is. We don't know what a is, so we can actually put it anywhere along here because we don't know what a is. We have no scale into the graph. Okay, so we have one of the roots, and I'll highlight these in red. We'll do these roots in red. One of them at x is equal to 0, and another at a third a. So I'll just write that, a third a there. Don't know what a is, so I'm just going to put a third of a to be on the x-axis there. Okay, now let's consider what the graph actually looks like. If we expand the brackets, we'll have 3x cubed minus ax squared. So looking at the highest power, we can see that it's a cube, so it's going to be a cubic graph, and it's positive, it's 3x cubed, so it's going to look like a positive cubic graph. So what we're going to have is something that looks like this. What I'll do is I'll highlight that in red and I'll draw the graph in red. It's going to look something like this. It's going to start down here because this is where the positive cubic graph starts. Start down here, come up. It's going to pass through this root, bounce off, come back down, so it can then pass all the way through that root like that. Okay, and that is the graph of y is equal to x squared times 3x minus a. Okay, And then we also want to sketch b over x. Sketching b over x is just like sketching k over x in the previous video. So sketching that, it's going to look something like this. It's going to have asymptotes, so we'll write those on and we'll do them dashed. Asymptotes down the y-axis and down the x-axis, and then it's going to look like this, and we'll do that one in green. So b over x will look like this. Not a straight line. Try and make it as smooth as the iPad lets me. Looks like that. And then we'll also look like that as well. Okay? Maybe a little bit like that. So we can see that is the graph of, write it in green, y is equal to b over x. So those, that's part A, those are our sketches. Part B then says, using your sketch, state with reason the number of solutions to the equation. Now, this is the equation that we're wanting. I can do a slight little trick here, and I can add bx to both, or b over x to both sides. And if I do that, what do I end up with? I end up with this. I'll write it down here. I'll just bring this down so we can see what I'm doing. If we duplicate this down here, if I add b over x to both sides, what I get is this. X squared times 3x minus a is equal to, that's going to disappear, that's going to cancel out, and on this side we'll get b over x. Note that those are the two equations, or the two graphs, I've just sketched. So all I'm actually doing by solving this equation is solving the intersections of the graph, because we've got one graph equal to the other. So I'm solving the intersection. So all I need to do to state with a reason the number of solutions is just have a look at my graph and see how many intersections there are between the two graphs. Well, if I highlight them in yellow, there's one intersection there, and there's also another intersection there. That's why it's really important to get your graph correct. I can see I've got two intersections, so we'll write it here. Two solutions, I should say. Two solutions to the equation x squared times 3x minus a minus b over x is equal to 0. And then we need to state with a reason. So because there are 2 points of intersection between x squared times 3x minus a and, sorry, I should really put y is equal to, and y is equal to b over x.